In this video, we'll examine classification and nomenclature of amines. Amines are compounds of nitrogen. They can be considered to be derivatives of ammonia. We already covered ammonia in the first chapter, so ammonia has formula of NH3, and amines are compounds in which one, two, or all three hydrogens of ammonia are replaced by hydrocarbons. Those hydrocarbons could be alkenes, alkynes, alkenes, some of those kind of groups. Pretty much any hydrocarbon. And in fact, those hydrocarbons could even have other substituents, such as oxygen or other heteroatom substituents. Compound is still amine. According to degree of substitution of nitrogen, amines are classified as primary, secondary, or tertiary. And this is very important. It's degree of substitution of nitrogen. Previously, we covered classification of alkyl halides and alcohols, and those classes of compounds were classified according to degree of substitution of carbon. Amines are classified according to degree of substitution of nitrogen, not carbon. So here are examples of, or general formulas of primary, secondary, and tertiary amines. Primary amine has nitrogen attached to one carbon atom. So there is one group R, it may be alkyl group or something more complex. So that's primary amine, and as you can see, remaining two bonds are nitrogen-hydrogen bonds. In case of secondary amine, nitrogen atom is attached to two other carbon atoms, which leaves remaining bond as nitrogen-hydrogen bond. Those two groups that nitrogen is attached to could be identical, as in this highlighted example, or they could be different. And finally, in case of tertiary amine, all three nitrogen bonds are to carbon atoms. So we have three nitrogen-carbon bonds. That means there are three hydrocarbon groups attached to nitrogen. Those three groups could be identical, or we could have example where two are identical, third different, or all three could be different. Finally, there is an entirely different class of compounds, and those are quaternary ammonium salts. So those are salts, those are ionic compounds. In them, nitrogen has four substituents. So it is attached to four other carbon atoms, and that way it forms ammonium cation. And that ammonium cation is accompanied by counter ion, by negatively charged anion. That anion could be halide anion, maybe hydroxide anion, bisulfite anion, so pretty much any negatively charged ion. Common or trivial names of amines are descriptive. So substituents are named and listed in alphabetic order. We first name substituent or name substituents if there is more than one, and that's followed by suffix amine. The entire name is written as single word. So here are some primary amines. We name the substituent. In the first example, that's isopropyl, so compound is isopropyl amine. Second example, isobutyl substituent, so compound is isobutyl amine. And then this third example is very important. Note the name, aniline. It's a little bit unusual structure. It has benzene ring attached to amino group. This name was given to compound when it was discovered, and that's the only name that we use for it. We could name it differently, but that's the only name that we use for it, aniline. And that name has been adopted both as common and as systematic name. So you have to memorize that name. Then some examples of secondary amines. So secondary amines have two substituents, and we list them in alphabetic order. So first example is butyl ethyl amine. Note that T is not alphabetized, it's separate from rest of the name by a dash. So it's B that comes before E, butyl before ethyl. Next example is secondary butyl methylamine. If two substituents are identical, we should use prefix di. So this is diethylamine. And of course, don't be confused by cyclic substituents. You simply use prefix cyclo. So this is cyclopentyl methylamine. And then there are some examples of tertiary amines. First one is ethyl isobutyl methylamine. So all three substituents are different and again listed in alphabetic order. or all three could be identical, as in case of triethylamine. And finally, two could be identical, third different, ethyl dimethylamine. So, when necessary, we have to use prefixes di and tri. You should keep in mind that unlike an ether, which must have two substituents, an amine can have anywhere between 1 and 3 substituents on the nitrogen atom, which means that prefixes must be used. So substituents that are present are named, and if there are fewer than 3 of them, then remaining bonds are understood to be nitrogen-hydrogen bonds. And just to summarize, first row are primary amines, second row secondary, and third row are examples of tertiary amines. Here is very important warning. There is very common exam mistake. This compound, and it's written or represented in two different ways as condensed formula and line formula, is tertiary butyl amine. This is primary, not a tertiary amine. Again, students keep forgetting that and keep looking at carbon atom because that's what they are familiar with. They learned an example of alkyl halides and alcohols, look at carbon atom, and they classify this frequently as tertiary amine. With amines, we have to consider degree of substitution of nitrogen atom. That's what classifies amine as primary, secondary, or tertiary. So this is primary, not a tertiary amine. To name an amine according to UPAC or systematic nomenclature, one should identify the longest chain of carbon atoms that is attached to the nitrogen atom. Next, we name the hydrocarbon, drop the final E in its name, and replace it with suffix amine. We should use number to indicate position of the nitrogen atom as necessary. As a general rule, if there are more than 2 atoms in a chain, one has to use a number to indicate position of nitrogen atom. So in the first example, compound is named as methane amine. Longest chain is 1 carbon, so methane. We drop the final E, replace it with suffix amine, so this is methane amine. Next example has 2 substituents on nitrogen. When there is more than 1 substituent, the longest chain containing the amino group is the parent name, and the remaining groups are named as substituents. So here we have 1 carbon chain and 3 carbon chain attached to nitrogen atom. So 3 carbon chain will be the parent chain. Nitrogen is attached to first carbon of the chain, so it is going to be 1 propane amine. That's propane chain. We drop the final E, replace it with amine, so 1 propane amine. Substituent is methyl group. But because this methyl group is on nitrogen, we don't use number to indicate its position. Instead, we use capital letter N, and in print that letter is italicized. So capital letter N indicates that substituent is on the nitrogen atom. So systematic name of this compound is N-methyl-1-propane amine. And here is another example, N-methyl-2-propane amine. Simply related compound, isomer, where nitrogen is now attached to carbon 2 of the chain. Tertiary amines have 3 substituents. So again, we identify the longest chain. That's the parent name. So it's again 1 propane amine. There are 2 methyl substituents. So now we use 2 letters N to indicate positions of 2 methyl substituents and prefix di. So this is NN dimethyl, 1 propane amine. So note that symbols N are treated as numbers. They are separated from each other by commas and from rest of the name by a dash. And one more example, a little bit more complex, with substituents both on the carbon longest chain and on the nitrogen. So in this case, longest chain has 6 carbons. So it's going to be hexane amine. And nitrogen is attached to carbon 2. Often students make mistake here and assume that nitrogen is attached to carbon 1. So name this as 1 pentane amine, and then name it 1 methyl or 1,2-dimethyl pentane amine by naming this first methyl group in a chain as substituent. Don't make that mistake. So correctly identify the longest chain, That's 6 carbons, hexane amine, and nitrogen is attached to carbon 2. So 2 hexane amine. On carbon 3 of that hexane chain, there is a methyl group. So it's 3-methyl 2-hexane amine. And finally, on nitrogen, there is ethyl substituent. So complete name is N-ethyl 3-methyl 2-hexane amine. This is another example how naming works backwards. So from the root of the name, from the parent chain, all the way to the first listed substituent. Finally, quaternary ammonium salts are named as derivative of ammonium salts. That's basically as inorganic compounds. Hopefully you recall from general chemistry course how inorganic compounds are named, specifically ammonium salts. For example, ammonium chloride, ammonium bromide, ammonium hydroxide, ammonium bisulfate. So they are named as ammonium and then anion. There is space between cation, ammonium, and anion when you list them. Now, if ammonium ion is substituted, then you apply rules you just learned. So all the substituents are named, and they are named as alkyl groups. So in this example, we have 4 methyl substituents. So this is going to be tetramethyl ammonium chloride. This completes our video on nomenclature of amines, and next we are going to examine physical properties of organic compounds.